all doing? My name is Pablo. I am the founder of the Data Science Mentor Program. The Data Science Mentor Program is helping data science learners go from 0 to 100 using examples and mentorship. Right. So it's already a program. It's been going on for a bit, and so we're already doing a lot at this point. But today, what we're looking at is multinomial, naive, Bayes. We've been looking at the Bayes. It's part of like a category, family of algorithms, you know, which are called like the naive Bayes algorithm. Right. So we've been looking at it. If this is your first time, then it typically means you need to go check out what we have been doing. But also, this is a point for you to learn bits and pieces of what this ML algorithms do and their use cases. Now, today we're going to be looking at the intuition for a multinomial naive Bayes. And yes, we're going to build the intuition from here. So I'll start off by building on intuition. Now, what's the intuition for this algorithm? So you think of it as a word counter classifier. So we start off by calling this a word counter classifier. So a word counter classifier. So that's one. So when we say word counter classifier, what does that basically mean? So that means it looks at how many times words appear maybe in a document or a text, and it tries to figure out if there's a category for which these words belong to. Now so that's one of the intuitions, right? So just to put it, it looks at how many times words appear. Now it could appear anywhere. It could be as a text, or it could be in a document, appear in a text / document. That's what it does. Right. And what we are trying to do is, if it looks at it, it could tell, like, if there's a number of words, it counts the number of words that appears, then it can probably make a sense or predict if this word belongs to a category. Because the whole idea of an ML algorithm is to make predictions, right? So it looks at how many times words appear in a text. Then it goes on to make predictions with that. Now here is a perfect analogy for it. So here I could say, if an email contains some kind of text, right? If it contains some kind of text, then it can be, some kind of text, right? Then, and when we say some kind of text, we could now look at how many times it occurs, right? Then it can be flagged as spam or no spam, or ham, just as it is. So you see how that is. So this is like a simple intuition for it. Now the question is, what are the real world? What's a real world use case? Again, so we can look at this and say real world use case or use cases. So real world use cases for this could be, we could have of course spam filtering, because this is what I mentioned here. spam filtering. We could have sentiment analysis. Right, so we can predict whether a review is positive or negative. We can have topic classification. Right, so here we could sort stuff into sports tech, politics, you know, podcasts and stuff like that. You know, we could put things in perspective. So this is basically what the multinomial naive Bayes algorithm is all about, right? So you can do it a lot. You can do it like you can think about it. So now what we're going to do is we are going to basically do a walkthrough, and we'll do a walkthrough of what we want to do, and we're going to write code to do that. Now, we're going to do this like a classifying text. So we're going to have an example. So the example is going to be text classification. So it's going to be. Now, to that end, if it's a text classification, it makes sense that we'll just have data. So we're going to go to sklearn's estimator for importing text data. So I'm going to go from sklearn.datasets. Yep. Then we're going to import. Now, just so you know, just let me just reduce the stuff I have going on here. So if we have a situation that will work with, we could say sklearn, just to look at the estimators we have, data set. So you can see it has a documentation, has a bunch of data sets inside. So you can see what we're going to be working with. We're going to be working with this news groups here. So you can see that it has a bunch of classes. There's 20 classes. It has sample totals over 18,000, and it's text. So that's what we're going to be working with. And so I come back here. So let me see if I make this a little. Yep. So I have this. So we're going to import. We saw that here, fetch underscore 20 news groups. So that's what we're going to do. From sklearn, after history saving track data and unexpected error, history will be written in the database. Okay, that's all. That's okay. Right. So the first thing we're going to do is we're going to take data, and the data is we are going to now call the fetch news groups. That's what we're going to have. And that data we have has a bunch of things in it. So it's going to have, we can look at target names, target underscore names. So if we put this down, you can see that there are a bunch of target names here. And this should be 20, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How did I know about that? Of course it has 20, but the classes are 20 over here. Now, so we have this. Now, what we're going to do is we're just going to take a few of this, right? We're going to take a few of what we have here, and then we'll make them as categories, and then go ahead to train a part of these categories, and then see if we can make predictions on them. It's basically a very simple thing to look at. right? So we have, let's call this cat, right? So with cat, what we have is we can typically look at stuff. We can typically say, let's take this here. Let's talk religion there. So this is one of the categories we're taking. Then I don't see any other thing. We can also jump on this. Then let me see. Okay, we could take sci-fi, sci-space. And then finally, we could take we could take this. So, right, so we have this set up. Right, so we just have this as categories that we're going to be working with. Now, what we're going to do is we're going to create train. And if at this point, you know what, we're going to have our train and test. And if this point, you know that we're sort of what we're doing is creating a feature matrix. And this feature matrix is going to have a target vector. That's what we're doing, because that's how the sklearn estimator does its data representation. So that's what we're going to work on. Then we can now go on to use machine learning to see how we can do some sort of like prediction, but like counting the words, right? Because we talked about the word counter and all, right? You know, it's part of what you want to do. So this is the first part of it. So what we're going to first create the data, and then the next part of what we're going to do is we will now go on to create we would now go on to use our model class to do some, we convert, of course, convert it to vectors, then go on to use our model class to do some prediction. Then we'll visualize what we have done. Right. So so this part is where I'm putting together the data. So here I'm going to say fetch, so which is what we have. Now I'm going to use, inside fetch, I'm going to use a subset, right? So this subset here is going to be our train. Now in our train, I'm going to say cat. So our categories is going to be equal to cats, because we're going to look at this guy. That's what we're going to reference. Then we'll have our tests. And as usual, we are going to have fetch and have our subsets. And our subset is going to be our test. And our category is going to be cat. So this is what we have. Right. And so we have this. We'll run this. We shouldn't have a problem with that. Next, we are going to do is we're going to look at our data itself. So we have train, which is the data we have. Now, let's say train.shape. Let's see what we have here. Oh, I shouldn't have done that basically, right? Hold on, because that was not what I was supposed to do. Because if you look at this, if I was to put type, you see that it will tell you that this is an sklearn bunch. So what I'm going to do rather is I'm going to sort of like use a square bracket and say, I'm going to say no dot data. So this is what we have. The train dot data is what we have, and you see that it's a lot like this. And at this point, if I was to put this, here, what's going on, guys? Sorry, guys. Yeah, so it's now a list. So that's what I wanted us to see. But now we have a list. And with that list, I can now maybe now say, look, with our first list, let me look maybe at the first in the index here. And then from this index, I can look at, I can choose to bring out maybe slice maybe the first 30 aspect of it. Right. And yeah, then let me print this. So you can see that, right? You can see what we have here. So we have we have this information here. See Don McGee, subject federal hearing, right? You can see all that originator, organization, School of Ocean and Earth Science. Yes. So you can see all this. This is typically the data we have here. Now, for us to use this data for machine learning, we would need to convert, we have to convert the strings we have into a vector, right? And how do we do that, right? Now, to do that, we are going to convert strings to vectors. So let me have this. Convert strings to vectors. So this is what we have here. And now to do that, we would have to import the model class that makes that possible. So we're going to say from sklearn, dot feature extraction, we are going to import, no, is that correct? Sklearn, no, feature extraction dot text, yeah. So we're going to import TF vectorizer. That's what we're going to do. Also, from sklearn dot naive Bayes, which is a family of algorithms we're looking to work with. So we're going to import the multinomial naive Bayes. Then remember that we had learned initially from sklearn dot pipeline, we're going to import make pipeline. So we're going to import make pipeline. All right, so that's what we're going to do, right? And so we've run this now. So we would did I make any mistake? Oh yeah, there was. All right. Now what I'm going to do is I'm going to instantiate our model. Remember, it's part of the 4 to 5 principles, the 4 to 5 steps we take. So I'll instantiate the model. And in the model, I'm going to say make pipeline. Right, when I make the pipeline, inside my pipeline, I'm going to have my TF vectorizer, which is one of the first things I want to set up. And then I'm going to get my multinomial this. So this is what our model is going to do, which means it's going to take it's going to capture our string data, do some conversions, vectorize them to numbers, and then go ahead to do some stuff with it. Right. So that's where I'm going to stop for this first part. Next part, look out for it in the next video. We are going to be, fitting a model and then go on to do a predict and then see how well that performs.